been doing Python for quite a while. Kind of started after I dropped out of grad school and kind of worked in scientific programming, in atmospheric science, and I've worked in urban planning and astronomy, now kind of in healthcare and software engineering. It's great to be here. Thank you all of you for coming. What I want to do today is talk to you about Airflow, which is kind of a workflow management and orchestration tool. Don't worry too much if that's all gibberish. That's what this talk is about. And I kind of want to leave you today kind of with an idea of what Airflow is, what it's useful for, when you might use it, and things that are good to know before you kind of jump into Airflow, so you kind of know what you're getting into. So about Clover, we're a health insurance company based here in San Francisco. We use Python for everything, so all of our data stack and our web stack and our data science team, all using Python. We're hiring engineers and data scientists and analysts, so check out our website, or go visit our table outside. We've got a table out there with some swag, and you can talk to some engineers from the company. I'm on the data platform team there at Clover. Like I said, I've been using Python since 2008 when I started making plots and figures of satellite data. I go by Jiffy Club on the internet, so on Twitter, for example, because Matt Davis was taken literally everywhere. Yeah. So let's give you a quick outline here. So I'm going to talk about where Airflow came from, what you use it for, give you a tour of its UI, talk about what the system looks like when you put it out into production, kind of how the code works to actually build things to do in Airflow, and then some good stuff to know before you get started. So Airflow came originally from Airbnb, developed by a guy named Max, and Airbnb is still doing a lot of the development and maintenance, but this year, Airflow became an Apache incubator project, so it's going to kind of go under Apache's governance, which I think is a good sign that it'll kind of get more of a community support and be around for a while, hopefully. And hopefully Clover will be part of that too. So what does Airflow do? What do you use it for? I think this is a pretty common problem for people doing all kinds of things. You have a thing you want done on a schedule. A really common use case is like an analytics workflow, like you want to compute all of the usage analytics for the last day. But it can be really anything. You want to send a bunch of emails, you want to copy some files, like whatever. But the schedule part of it is important because Airflow really here is the alarm clock. Airflow is the thing deciding what to run when. The rest of it, like what actually happens, that's you. That's where you actually are writing some code to make stuff happen. And so there's kind of the Airflow deciding what to run when, and then there's you writing pipelines. Pipelines are collections of tasks. In Airflow terminology, they're DAGs, or directed acyclic graphs. I like to call them pipelines because I think that's a more intuitive term. So you can have one or more tasks connected together by the order in which they need to run. So this dependency graph is why it's called a DAG. You can't have cycles in this or your pipeline would never stop running. So it's a directed acyclic graph. And so you build up this pipeline of tasks that have to run in a certain dependency order. They don't have to depend on each other, but the nice thing is that they can. You want this thing to run before this other thing. And one advantage of defining it this way is that Airflow will run things that are independent in parallel. Right? So the two tasks on the left side of this, they don't depend on each other, so they can run at the same time. So Airflow can take care of that, run them both at the same time. But the task in the middle can't run until both of those are done, and it won't. And then once that one in the middle is done, all three of its downstream tasks can run in any order or all at the same time. And Airflow can take care of that for you. A big advantage of it. So what can these tasks do? really anything. I'm only being a little facetious because you can write Python, right? And Python can do anything, as we know. But there are built-in what are called operators in Airflow that are, of course, they're Python under the hood, but they're pre-configured to do things like send SQL statements to a database, or go out to a subprocess and run a bash command, or run a command in Docker, for example. And there's a lot more of these, and there's a system for writing your own operators that have a certain kind of configuration. At Clover, we use Postgres as our data store, so we use the Postgres one a lot. We use Bash and Python operators quite a lot, and we've built up a bunch of custom ones that encapsulate certain very common operations, like calling pgdump to dump a bunch of stuff out of a database, for example. So let's take a quick look at some of real pipelines from Clover's usage. Here's one. That's the entire pipeline. It's a Python function that gets called in a schedule, runs every morning. A more complicated one has several tasks that have to run at the beginning, and then it can kind of fork out into two independent streams, and those things can run at those two streams can run independently. And if one of these fails, so if there's a task failure on the upper fork of that, it doesn't affect the downstream, the lower fork of that. That can keep running independently, which is another thing about nice thing about letting Airflow run this, is that task failures in independent parts of the pipeline don't derail the other parts of the pipeline that are independent and can still run. And then we have this monster, which is this is going on 500 tasks now, interdependent in kind of pretty complicated ways. This view on the view on the right is taken from the same UI that the previous screenshots I was showing you. The view on the left is a different kind of view on this I built. You can't tell, but those are all arrows pointing at the next downstream task. So it's a pretty complicated thing. And when we picked Airflow as our system, we knew we had something like this. And so we picked Airflow for its ability to run something like this, run different parts of it separately and in parallel, and to be able to, when one of these fails, deploy new code and restart it and rerun just the part of it that had previously been affected by a failure. Because this thing takes quite a while to run, and in our old system, this would get derailed. If it failed partway through, we would have to start over from the beginning. But with Airflow, we can only rerun the parts of it that were affected by the failure. Is there a question here? Yep. So the question was how does that work, and what allows that to happen? I'll why don't I get into the UI, and that's perfectly into the Airflow's UI, which we'll get into next. So Airflow has a UI that ships as part of it. So in addition to scheduling and running things, it also gives you a whole UI so that you can watch what's going on. This is the main view, which is a list of all of your pipelines. And their status. So under the schedule column, if it's red, those ones are running right now. The recent statuses shows you the status of tasks in that pipeline. The color indicates whether they were success, whether they're currently running, whether they failed. So the red are failures. So you can kind of see what their status is. You can click into these to kind of get a view of I see the task failed. Let me click on that and go see which ones failed. And then over on the right, the links column has links into several different views for that are specific to each of the pipelines. One of my favorites is the Gantt chart, which shows you the order that the tasks in the pipeline ran and how long they took. So this gives you a really quick view into which part of the pipeline are taking up a lot of time. And this updates like in real time as a pipeline is running. You have to hit refresh, but you can sit there and hit refresh like as your pipeline is running and watch this fill in, which is kind of handy. You can click on one of these bars and, well, let's take a look at the top here where you see graph view, tree view, all those other things. The graph view is how I got those screenshots I was showing you in the previous part. So there, Airflow will lay out the tasks with arrows drawn so that you can kind of see what the pipeline looks like. The tree view is another view on that incorporates previous runs of the pipeline. So you can see kind of on a line item of task and its status in the current run and in previous runs. The task duration is what it sounds like. That shows you how long each task took over in a historical view, which is also very useful for like looking at how different steps of your pipeline are trending as you add data, for example, over time. Or maybe you're like, whoa, this thing is taking much longer than it used to take. Like, when did that start happening? And that can help you track down the change that caused that to start happening. So that's a real thing we've done where we've been like, okay, this pipeline is taking 2 hours longer than it used to. Go into this graph and find like, okay, this happened on September 3rd. And then go back to September 3rd and be like, okay, what did we merge on September 3rd? And like actually track down the change that caused that to happen. In many of these different views, you can go into a little task view. Like if I click on one of those bars in the Gantt chart, it brings up this menu. And you can do things like change the state of the task. So when you wanted to rerun it, one of the ways we do that is by using the clear. And so it'll clear a task and everything downstream of it, which will make Airflow forget that it had ever tried to run it. And then it'll be like, oh, I haven't run these tasks, and it'll run them. So that's kind of one way of tricking Airflow into like rerunning something for you. It also has like, you can move tasks into an up for retry state, and it'll try to rerun those. The task details allows you to see all of the configuration of the task. So what were all of the parameters to the task, which can be useful. For rendered, a lot of tasks, for example, you might have SQL that's been parameterized. So Airflow has a templating engine. It allows you to use Jinja to build up templates of SQL or Bash scripts and have things substituted into it using Jinja syntax. And so you want to see the outcome of that so you know what actually ran. That'll show up under the rendered view. And then the view log is something I refer to all the time. It's very useful, is the actual logs of the task. So if there was an exception in the task, it'll show up there in view log, and you can kind of troubleshoot and find out what was going on. And if you've written good logs for your tasks, they'll show up there too. That's it for the tour of the UI. There's also a really good tour on the Airflow homepage of the UI that you can check out. So what does Airflow look like? What does the actual system look like when you put it out into deployment? What are the pieces you need? You need a database, a SQL database. So Postgres or MySQL to hold the metadata. So this holds the record of all of the pipelines that are running and have run, all of the tasks that have run. So all of that historical information, when you go to task duration graph, it's doing a query on the database, on like the task table in a database and pulling out the information. So it's storing when it ran, when it stopped running, state, stuff like that. So this needs to be a persistent, stable database to hold the information. We use Postgres, or you can use MySQL. In theory, you can use SQLite while running locally, but I've never actually had that work. So you kind of, even if you're just like toying around with this locally, you do need to get like a Postgres server running. Another component is a web server that you need to deploy. All of those screenshots I've been showing you came out of the web server. It's a Flask application. It needs to be able to talk to the metadata DB, but it doesn't have to be a big thing. It's a little Flask application that talks to the database and then serves up those UIs. Another process is the scheduler. This is a Python process that's kind of running in a loop, checking the time, checking the current time against like all of the pipelines that you have scheduled and seeing if any of them are due to start running, checking for within the running pipelines, checking which tasks are eligible to run and putting them out on the queue, checking whether they're done, updating the state of the tasks in the database, stuff like that. Again, it's pretty, like both the web server and the scheduler are pretty lightweight processes. They don't actually do a whole lot. They can run on small machines. They can run on the same machine. But you do need something doing work. So you need workers. The kind of default recommended setup is to use Celery, which is a older and very popular like work distributed task queue system in Python, where you have a server and then you can start up workers on different machines and they talk over a queue. So you need a queue for the Celery to talk over. There's Redis, or you can use RabbitMQ for that. We use Redis, so you'll need a Redis database for this. And then they can talk, and so there's an Airflow command line interface where you can go on these different machines when you're deploying and say Airflow web server, and it starts the web server, and Airflow scheduler, and it starts the scheduler, and then Airflow worker out on your distributed machines, and they start up Celery workers, and they're all configured to, there's a master configuration file that tells them like what queue or like kind of what Redis database, for example, if you're using Redis, what Redis database to look at for incoming tasks and for reporting task status. So this is a pretty like kind of, if you have a kind of like the full-blown distributed computing like example of this, it is a few things. You need a metadata database, you need a web server process, a scheduler process, and a bunch of workers communicating via Celery. That can be a lot, and that may be, this gives you good separation between these different components, but it's also a lot of things, which doesn't always work for everyone. And so you also have the option of running the workers on the same machine as the scheduler via multiprocessing. So I'll cover this in a little bit, but there are executors in Airflow, which are different ways of running these tasks. Celery is one. There's another one that does it via multiprocessing. So it'll create new processes on the same computer as a scheduler to run your tasks. So that couples your workers and schedulers together very closely, but they you have much less deployment to do. So that actually like works for some people. At Clover, we use Celery and Redis and everything, but some people get away with just using this all locally. So what does the code actually look like when you're putting all of this together? The first part of this is usually to create a DAG. It's actually called DAG in the code. You have to give it an ID, which has to be unique among all of your DAGs. You give it a start date, which is the date on which you want it to start running. Usually this is like the same date you deploy it, but if you put this far back in the past, Airflow will create runs starting from that start date, going up through the present according to the scheduled interval. And you can use this to do backfills if that's important to you. And the schedule interval is Here it's a cron expression, so that's the same expression out of cron. So that's like every day at 10, we'll run this, but you can kind of put in whatever you need to do there. Yeah, I'm okay. I'll be okay. Thanks, I'll be okay. So what are some, so we looked at the configuration we had here were the ID, the start date, and the interval. There are some other useful things you can do with the DAG. Default args are arguments not for the DAG, but for the tasks you're going to put into it. So they share a lot of usually the task you're going to put into a DAG will have a lot of the same configuration, so you can kind of put it all in a dictionary here and then save yourself passing it into all of the tasks you're going to put here. Max active runs is how many instances of this pipeline can run at the same time. So we often set this to 1 because we only want one of this task running at a time. And especially helpful if like something happened and it failed and it took you a while to fix it, and if this was not set, it would, like you missed several runs, Airflow would like schedule all of those at once. And they would all run at the same time, for example. So this gives you some control over that. And then the concurrency flag is how many tasks within the DAG can run all at once. And this in theory is useful if you have like a really complicated DAG, like the huge one I showed you, where like 100 of those might be eligible to run at the same time. And you don't want that because it would kill your database. So you can kind of set an upper limit on that. Right now, we've actually not seen this flag doing anything, so it might be a bug around this right now. But it's there in theory. And I'll talk about another way to use to do the same thing. So how do you create a task? You pick an operator. This is the first thing. So here's an example is the Python operator. You give it a task ID. The task ID has to be unique within the DAG or within the pipeline. And then we're telling you which Python function to call, and then which DAG it's part of, which pipeline it's part of. So when we add another one, pointing at another function with another unique name, and then we give them a relationship. We say, second task.setUpstream first task. This tells Airflow, don't run second task until first task is done and successful. And then you can make more of these and connect them together in whatever way is sensible for you. And that's how you build up a pipeline, is by setting up these relationships between individual tasks. Some useful task arguments are, sorry, just a second, are retries. So say it's okay if a task fails, you just want it to try again. So you can set retries to some number, and then Airflow will say like, okay, it failed, we'll try again. Pools are a concept where you can create a pool in Airflow and say, there are 6 workers in this pool. And then all tasks assigned to that pool have to share those same 6 workers. And they're not specific workers, so they're not specific Celery processes or anything, but it just means that only 6 tasks assigned to that pool can run at the same time. So this is another way, instead of using the concurrency flag, which doesn't seem to work right now, you can use pools, and we do this at Airflow. If you're using Celery, you can assign tasks to a specific queue, and then on the workers, have them listening on a specific queue. So this is a way to associate tasks with specific computers. So unlike, which is not what pool does. So if you have tasks that use a lot of memory or a lot of compute power, you might associate them with a certain queue that's running on a computer with a lot of memory or a lot of compute power. Other tasks that, for example, like SQL tasks, they don't do anything. All they do is pass it off to the database and then wait for a response to come back. So they don't need a big computer. So you can kind of steer specific tasks to certain computers using these queues. Execution timeout is how long Airflow should wait before failing the task. So if a task takes longer than some certain amount of time, it kills it, and it's a failure. Trigger rule Normally tasks, by default, tasks only run if every task upstream was successful. But you can tune that. You can say, run this task as long as all upstream tasks are done, whether they failed, succeeded, or never even ran, but their turn came up. Or you can say, if every task upstream failed, run this task, for example, so you can tune that. You can specify arguments for Python functions. You can specify environment variables for bash tasks. You can specify template variables for bash or SQL tasks in Python so that you can parameterize those. So the power of this gets really powerful when you realize that you can do things like this. You can put that task creation in a loop and start building up a task for some individual set of things. So if you have a bunch of files you want to copy or parse, loop over those files and create individual tasks for every single one of them. And then put them all downstream of some like setup task. In that huge pipeline I showed earlier, all of those tasks are created by YAML configuration files. So like we weren't going to like hand program up like 500 individual tasks. So we came up with a system where analysts can write SQL in .SQL files, or they can write little bash scripts that call out to Python or whatever. And then they create a YAML file that says, here is the file to run, and here is the other task that it depends on. And then we programmatically parse that into a graph that makes that huge thing. So you can get really creative about how you make these tasks in Airflow, and that's like really a really powerful aspect of it is the ability to programmatically build the pipelines according to whatever system you have. I was talking to somebody who was thinking about putting configuration and JSON files on S3 and like pulling that down and using it to kind of programmatically create pipelines. Kind of the world is your oyster in this case. So finally, some things that are useful to know about Airflow, some tips, tricks. One is the executor types. So we use Celery in production. So this means Airflow is expecting to be putting tasks onto a Celery queue. Like Celery is an utterly different project than Airflow that has been around for much longer than Airflow. So I just want to make that clear that it's like a totally different thing, but it's a tool for putting tasks on a queue and then having n number of workers pick up and execute those tasks and report on their status. So you can do that. Sequential Executor has tasks running in the same process as the scheduler. So the scheduler will stop doing its scheduling work and run the task and wait till it's done before picking off the next task. And that's useful when so it can only do one thing at a time, but that's useful when you're doing local development because there's like nothing fancy going on. Like it takes some things out of the equation in terms of debugging and stuff, and then the next slide has a little more about that. The local executor is the one that does multiprocessing. So the task will run on the same machine as the scheduler, but it'll do a bunch of them in parallel using Python's multiprocessing module. So it can keep doing its scheduling, and it can run many of them at the same time and kind of juggle that. And if you have like a really big machine, like you can potentially run a lot of these at the same time on the same machine as the scheduler. The downside is if, for example, if for some reason you wanted to restart the scheduler, or you wanted to restart, if you wanted to restart the scheduler, you would be interrupting any running tasks to do that. That's fine. Like that could be fine for you depending on how often things are running. So if you can kind of get this all over within a certain window of the day and then do deployments and restarts, like no big deal. But at Clover, we're running tasks like 24/7. And we want to have some independence between the workers and the scheduler. There's also a community contributed Mesos executor. So if you have an existing Mesos cluster for doing distributed computing, you can also submit jobs to that from Airflow. So this is a tip for local debugging. Because Airflow kind of in production mode is either running things in parallel on a distributed task queue or in a multi-processing way, you don't have access to those processes when they fail. And you can't do things like import PDB, pdb.settrace. But if you use the sequential executor, it keeps everything in one process, and you can do this. So you can actually put a breakpoint in your DAG creation code or your task code if it's Python, and actually kind of stop and do interactive debugging. But you still need to have like a command line to do that at, which is where Airflow's command line interface comes in. You can do pretty much all of Airflow's operations, like creating a DAG run or kicking off a task run from the command line. I don't often do that. In fact, I never do it. But the one thing I do is use the Airflow test. This will run a task without updating a database or kind of any of the surrounding tracking around it. It just runs it. And this is really useful for testing when you want to just see what happens. Like you're tracking down a bug or something, doing some local development, you can do this. But if you do set trace, the sequential executor, and then Airflow test, you can actually drop into the Python debugger and do introspection there. Another thing related to local pipeline testing, when I'm actually putting together a pipeline and kind of doing end-to-end testing, I might be using something like the local executor to run it in parallel, so things can run in parallel and go faster than with the sequential executor. But I don't want to deal with like Airflow being like, oh, I need to like run 15 of these. I only want it to run once, so I can do my testing. And there's a special schedule interval of the @ and once, which means only run this once ever. So it won't get carried away and like create a million instances of this pipeline run. I put the start date at some time in the past. It doesn't matter. I just want Airflow to know it has to run it, like its time has come. And then when I want to rerun it, I go into the UI and say, like, delete all tasks associated with this DAG, delete the DAG run record associated with this DAG, like delete everything so that Airflow never knows it, doesn't know anything about any past runs. And then it'll be like, hey, look, a pipeline I need to run, and it'll do it. So this is kind of a quick way to do a lot of like quick iterative local testing without dealing with like, well, is it time for it to run? Or like, oh shoot, it's going to try to run it 15 times. Kind of, you don't have to deal with any of that. This next one is a fun one. To uniquely identify things, Airflow is putting together a combination of DAG ID or pipeline ID, task ID, and then an execution time. So there's this idea that every pipeline run is associated with a certain date and time that uniquely identifies it. And you might naively think that the date associated with it is the date at which it was scheduled to kick off. You would be wrong. I mean, you would be right, but that's not how Airflow does it. So the way it does it is that the execution time associated with a pipeline run is not the time it was scheduled to start, but the time the run before it was scheduled to start. So the execution date associated with the middle run here is the date associated with the date at which the previous run was scheduled. That's a good question. I'm not sure how they handle that. And like, this is a really confusing thing that trips people up all the time at Clover and everywhere. I think they designed it this way because they were kind of conceptually not thinking, the designers were kind of conceptually not thinking so much about the actual date, but the interval between the current run and the previous one, because they were doing like aggregation metrics over that interval. And so they would be like, they wanted to make it easy for the people writing code to be like, I'm going over an interval from the execution date plus 1 day, because that would get like the previous day's metrics. But as soon as you get out of that world of like 1 day scheduled chunks running at midnight, like this stops making any sense at all. But it's something you have to watch out for. So I post this like in our Slack and being like, don't forget, like this is how Airflow time works. So remember that when you're looking at the pipeline run list, the time there where it says execution date is not the time the pipeline ran. But if you go look at the logs or something, the timestamps there are the actual time it ran, once you account for any time zone differences. This is just some general advice to don't mix Airflow logic and your pipeline logic. Keep those separate so that you can like run and test your code without having to involve Airflow at all. And this is just about like being able to separate bugs and being like, okay, when I run my code, it does the thing I expect, but when I have Airflow run it, it's not working. And so you can kind of be like, okay, this has to do with my scheduling or my pipeline dependencies or the dependency graph. And it's just going to give you a way to troubleshoot that. If you have too much going on where you have to be running Airflow to like see the results of your code, now to run an entire pipeline, you might still have to get into Airflow and have Airflow run it. But for the individual tasks, you kind of want to separate these to the degree you can so that you have confidence in them separately. Because like Airflow running in like a distributed computing environment is going to go throw a whole new like suite of failure modes at you that you kind of don't want to be debugging in conjunction with your actual logic. So like I'm working on a project right now where I have still not written any Airflow integration code. I built a CLI into it and like call it from the command line to actually test it. When you want to deploy new code, this can get challenging because the Airflow scheduler and workers are long-running Python processes. That means if you put so you've probably all run into this, especially if you've done interactive computing, where you'll have like an IPython session or a Python session, and you'll change something that you imported, but it doesn't get reflected because Python caches imports. Same thing happens here. You can like deploy new code to one of these processes, but until you restart the process, that won't get picked up. Airflow does iteratively re-import DAG modules, so the definitions of DAGs get re-imported, but any things they depend on, not necessarily so. So you kind of have to jump through some hoops to, or at least we do, to regularly restart these processes so they pick up new code deploys. We have cron tasks on these, like on the machines, doing git pull every few minutes to pull in new code, but then we have to have a separate mechanism for restarting them. The scheduler has a num runs flag that causes the scheduler to like die after so many cycles of doing its scheduling loop. And so if you wrap that in like an infinite bash loop or have supervisor watching it, you can get it restarted every time it fails, and so that'll start up a new process. For Celery tasks, you can set this environment variable or config variable that makes the workers restart, like the actual underlying process restart after some number of jobs are completed. We're still fiddling with this and trying to get this to work. It's been a real challenge for us, and I think for a time we've had these set to 1, like literally like one thing happens and then we restart them. And that's costly. Like it costs you a few seconds when you do that, but that's fine. We don't care that much about a few seconds. Airflow is kind of like, this is I've seen this complaint on blog posts from other people using Airflow, so it's definitely a thing that's kind of in the community mind and might be addressed. Like Airflow has just come up with this idea of packaged DAGs, where I think you can put things together in a zip file and to deliver that, and Airflow will like re-import everything in the zip file, I think is how it's supposed to work. But we haven't tried that yet. But it's one thing to keep in mind that like you're going to have to do some like operational like deployment stuff when you're using this. So to kind of conclude, I'm going to talk kind of briefly about why we chose to use Airflow as opposed to anything else. A big one is that it's written in Python, and we use Python. So I've been into the Airflow source code, and so has most of the people on my team. And we can get in there and like find out what's going on. And like that's an important thing for something that we depend heavily on. And if we need to, we can change it, contribute back upstream. It has that nice UI I showed you, so we can see what's going on, and it's accessible to like our analytics team. They can go in and be like, hey, has the pipeline run today? They don't have to bug us about that. They can go look. If anything failed, they can go. Airflow has like task failure mechanisms that you can hook into. So we have it post to PagerDuty every time a task fails, and like we send certain ones to the engineering teams and certain ones to the analytics team with like links to the Airflow logs so that you can go like find out what happened if something failed. The programmatic pipeline instructions so that we can make huge pipelines without a human typing up all of those characters. And then just that it handles the kinds of pipelines we throw at it, which get pretty big. So those are some useful links, the Airflow documentation, Clover's website, and my website. And that's it. And any questions? So the question was, could you run more than one scheduler at a time? I think the answer is yes, in theory, because it's checking things against a database, right? Because like when it does something, it puts an entry in a database. And so for example, to schedule a DAG run, it's creating an entry in a database that says there's a running pipeline. And then the scheduler says like, hey, there's a running pipeline. I should schedule a task in that, and it figures it out. In practice, we've seen some sketchy issues in the scheduler itself, like where we see tasks executing the same task, executing multiple times in the same pipeline. And so I would want to first make sure that you are really confident in one scheduler process running before you threw another one in the mix. Okay. Yeah, so the question was, what other comparable systems are there? The only other one we looked at was Luigi, because that's the only other one written in Python. We didn't go with Luigi because it uses like an inheritance-based pipeline and task definition system. So you have to subclass like a task superclass in order to create a new task, and which makes it a bit harder to do the programmatic pipeline definition, which is like, so that kind of ruled it out for us, and we went with Airflow. That was the big one. Simeon?
Just a quick question. One, like I've got so many kind of queuing systems where I'm like, DAX if I'm trying to do fast math, Spark if I have data flow, if I have one task and another. Like, what's the reason for Airflow's existence? Like, what's its target?
Yeah. So the question is, there's kind of a whole suite of things that you might reasonably call like workflow orchestration things. That's what, like, I used that term at the beginning, but it told you almost nothing, which is why I had to give a whole talk. Like, it's a weird thing. So like Simeon mentioned Dask and Spark. Airflow is, and incomparable things are up at a very high level, where you might have a thing that's like, I want to run a Spark job that's going to create a table. Then I want to archive that table in S3, and maybe you want to move it to Redshift. Maybe you want to move it into Postgres. Like I've talked to people who are kind of like doing this sort of thing where they were like, I have some sort of Hadoop system where I have all of my, like literally all of their data. And so they use that to tune a model, but then they have model parameters that they want to use in production, And so they need to move those over to a SQL database, for example. And so kind of Airflow can be that thing that runs the Spark job to get the parameters and then moves those over to like a production database or something. So like Airflow is operating at that really high level to tie together different components of a workflow, where each of those components might be very different systems. So we, for example, use it, one of our big parts of it is like moving things from SFTP to S3, and then from S3 to S3, and then from S3 to a Postgres, like kind of thing. Like, so it's tying together very different systems. You had another question? You totally could, yeah. Celery can integrate, Celery, so if you're using Celery, you have to use something Celery supports for the queuing. It does support SQS. Or you can run your own Rabbit, or you can run your own Redis. You can use an RDS and provided Redis, for example. It's a Python package, so it's like pip install -r requirements.txt, or, you know, and then you have Airflow in that list, and then it installs Airflow's dependencies, which are like Flask and stuff. And so it's, in terms of deployment, very similar to like any Python web application deployment structure. Question here. Mm-hmm. Yep. So the question was, can you, instead of using schedules for the pipelines, use kind of an event trigger? The answer is in theory. I think from the start, Airflow was very much intended to be like a schedule-based thing. And so it has a couple of features that allow you to do event-based things. Like it has sensors where you can have at the start, or usually at the start, but anywhere in a pipeline, a sensor that's like waiting for something to happen on an HTTP endpoint, or waiting for data to appear in a database as the result of a query or something. And so it kind of just sit there until something happens, but it's still running on a schedule. There is now something called an external, or like, there's an operator that can create a DAG run. So you can have like at the tail end, or as part of another DAG, kick off another pipeline. So that's like one way to do that. There's still one on a schedule. Airflow, so kind of like where this is going is like you would want Airflow to have an API, for example, where you could be like, start a run of this DAG and give it an ID and a date, and it would do it. That doesn't exist. Airflow doesn't have an API right now. A lot of people want that, so I think it'll probably be on the roadmap. All that does, though, is create a row in a database. So when the scheduler sees that it's time for a pipeline to run, it creates a row in a database, and then some other loop in the scheduler sees like, hey, there's a row in this database for a pipeline that needs to run, and then it kicks it off. So we've toyed around with this idea of like doing that, right? Like, so writing, I don't know, like a library for Airflow that would be like, that would hook into Airflow's data model and actually create those rows and do the same thing the scheduler is doing, but when we want it to. We haven't done that yet, but like the system is conceptually not super difficult. So we're thinking of doing that until Airflow has an actual API instead. So that's not well supported now, but a lot of people want it, so it might get there. Yeah. So the question was, how many DAGs do we run? And we run on the order of 20. So I talked about programmatically creating tasks within a DAG. I've read blog posts from companies that are programmatically creating DAGs, and they do hundreds of them. So like you can kind of do a turtles all the way down kind of thing. Yeah. That's a little bit, I don't know exactly how that works, but like, you can clearly get creative. Question?
So, I work on a data team at a tech firm that is exactly experiencing EG, AWS, et cetera. And I feel like this would be a really great solution for our data team to kind of get a workload, not have to follow an operation. However, to kind of take it away from the technical and practical, on Monday, I'm going to have to go and talk to the DevOps head, tell him, boy, do I love this, and I think it's useful. And they use a variety of other schedulers and Happen and like this is where I actually find part of things that are Chrome and Ascon and all this other stuff there. Does Airflow basically in Python just sit separately and not worry about that kind of stuff? It's gonna like let me kind of pitch it in a way that's not anything else. It sounds like it does.
Yeah. So the question is about deploying Airflow in conjunction with like existing data systems. So you mentioned Azkaban. Like Azkaban is one of those other things out there that is in the same space as Airflow, but it's a Java tool. So like there might be some contention there, and it would depend which systems that's touching and stuff. Like in theory, like you're like I guess you should talk to them and find out. Like in theory, it can be its own thing, right? It can have its own database. It can have its own cluster for actually executing the jobs, et cetera. But if it's touching the same, but Airflow might, like if you're running SQL tasks or if you're running MapReduce tasks or something, it might be touching the same systems that like Azkaban jobs are touching. And if they can't coordinate, that could have unintended side effects. So I think long answer is like, you're gonna have to talk to them about it. Don't do things without your DevOps permission. Like they don't like that. Question here? So the question was about passing information between tasks in Airflow. So you can do that a little bit. There's this aspect of Airflow called XCOM. And so, for example, you can explicitly, like, Airflow explicitly exposes like a XCOM utility that you can like put things on. Or if a Python function returns a value, it can go into XCOM, but it's really simple things like a string. You cannot, for example, pass around a data frame or like an array of data. Like you can pass around strings and that's about it. So you have to be serializing results to somewhere in between task steps. Okay. All right, thank you everyone for coming.